let's see what else I missed in with the Sigma Chad. Anyway.
To understand gravity is to comprehend the shape of the universe.
Look, this isn't quite right. All right, not quite Sigma, because on the larger scales of the universe, dark energy, something we really don't understand, is much more powerful in a sense, right? Gravity really is only having control over the little local group of galaxies. Much bigger scales, dark energy takes over. So to comprehend the shape of the universe, or if you will, the geometry of the universe, which we can already, obviously gravity comes into it, but it's everything. You've got to understand cosmology, and there's a lot going on in cosmology. All right, so it's not just gravity. When in the early I was going to say the early universe, but back in the early 20th century, right, when Edwin Hubble first looked out at the cosmos and saw all those other galaxies and realized they're all flying away from us and the universe is expanding, which was a revolution in science, basically, in astrophysics. We thought we would see that everything was coming closer together. We thought, gravity, bitches, right? Like, we thought the universe was going to be all coming together like that because of gravity. Guess what? It wasn't. We saw the opposite. We saw everything moving apart. And we were like, hang on, this doesn't make any sense. No, and then, way more recently, we saw not just is the universe moving apart, it's expanding faster and faster. So we call that expansion, the accelerated expansion, dark energy. So why the universe is expanding? Well, there's a lot going on there, my friends. And, you've got to go learn about things called cosmic inflation. You got to learn about the Big Bang. You got to learn about all the early physics in the early universe, as well as everything else. And then you'll actually realize we still don't know. That's the answer. We don't. So the geometry of the universe currently is flat. Okay, what that means is, well, good luck trying to comprehend that, because it's not the same flat you're thinking. It just means if you were to travel in one direction, right, you'll never be able to come back to the same point in space. However, there is a problem here. The universe actually could be spherical still. It could just be so large that in our little pocket of the universe, it just appears flat. We could be looking at such a small little segment of this big spherical thing that it looks flat. And if we saw more of it, maybe if we saw what we thought we would saw is some curvature to the universe, right? And if there was even a little bit of curvature, it would mean it potentially comes back in on itself, right? And if you traveled in one direction, you'd eventually come back. But in saying that, that's somewhat not true. There's some other problems there. So yeah, that's a long-winded answer about what he's talking about isn't quite true. But in a sense, he is true, because you might have heard of space-time, right? And space-time is like we call it the fabric of the cosmos often in pop sci. And, it actually bends and warps when you put mass in it or energy in it. So putting mass in space-time bends the fabric of reality in a sense. And so that's what he's getting at. Why? Because what gravity is in general relativity is literally just the curvature of space-time. And so that's what he's talking about. So to understand gravity, he's right, really is to understand the shape of space-time. You can see, like, things are complicated. Physics is complicated. Yes, to understand gravity is to understand, like, the shape of space-time in reality, for sure. So, I've kind of gone back and forth here. That's fine.
And to hear the harmony that lies beneath. Let's begin the experiment. Sigma present. Barrier activated.
All right, so I wanted to talk about black holes, right? Because if you bend space-time enough, right? If you put and remember, I don't think I made this clear. This curvature of space-time is gravity. So in general relativity, gravity is almost like, not there. You just have curved space-time. That's gravity, right? But if you bend space-time enough, if you curve it enough, if you put enough mass in a place, which will curve it enough, beyond its Schwarzschild radius, you actually will collapse that into a black hole, that matter. So if you squash the Earth down to the size of a peanut, you'd get a black hole. You squash the star in our sky, the sun, down to the size of a small town, you'd get a black hole. And so I just wanted to say this because, you know, the curvature of these things, well, the singularity at least, which we're not sure if there is one inside. We think there is, theoretically maybe. Then it has infinite curvature. So the shape is not something we can wrap our head around. Let's leave it at that, right? The fabric of the universe is like being bent into infinity. Like, what does that even mean? And I think in some theoretical frameworks in physics, it helps you understand a bit more. It's being bent through higher dimensions in some interpretations in theoretical physics. And the bulk is sort of like all of the potential other, just everything, right? And the brain is potentially like this other spatial dimension, like a fourth spatial dimension, at least in general relativity, which is where this curvature is happening. So, you know, we live in 4D space-time. We live in, you know, 3 spatial dimensions, 1 temporal dimension. And so if you have another spatial dimension, well, in our 3D universe, you have black holes, which are curving space-time. And, you know, you've probably heard of wormholes, how you can potentially maybe control the curvature of space-time where you bring it back in on itself, or on another point, and that's a wormhole. Well, but what is it curving through? Well, it's curving through a high dimensional spatial thing, right? And that's what you call the brain. And then everything is what they call that the bulk. So that's one way to kind of physically interpret it. And that relates to what we were saying kind of in the last video, in the June stuff.
Intriguing movement, but inconsequential. Let's continue the experiment.
Justice reigns.
Is this the one we watched? This could be the one we watched. I mean, is that all we had to go on? Like a 13-second clip?
Fascinating, but what goes up must come down. A pattern forms,
You can't catch me.
and the data indicates
Very cool. So he's creating like black holes or something, right? Nah.
there.
But interesting to note, if you were to create black holes this small, they'd evaporate fairly quickly. And not just that, they'd have enormous amounts of Hawking radiation being produced off these things. I mean, maybe they're not, right? Because, like, you know, if you're just holding one there, it'd be destroying some, not necessarily destroying. We don't know if information is destroyed, but it would be consuming a lot of this stuff, right? I'm not pointing at him. I'm pointing like in any area there would be like presumably there's an atmosphere or something here, right? It would be consuming some of that, and it would start to have like a photon ring. It would start to have an accretion disk, and for stuff that crosses the event horizon, it would be swallowed. So it would not look like that. So I guess it's not a black hole.
The experiment is almost
Nice laugh.
concluded. Do you sense it? It's time for a graphitic flux. The universe sings to me.
Nice. That was cool.
Listen closely to the harmony that binds all things.
This guy seems pretty OP, no?
The universe is magnificent, isn't it?
Should we just call this guy what he is? God?
The universe is magnificent,
This is cool. I like it.
isn't it?
Wondrous. Yes, it is. Nice. I think there's one more video, Overwatch. The first VPN that can protect you from quantum computers. I created it. Come support your boy, and if you want to get to Venus one day, that's where we're going to, all the finances for this and future endeavors, we're going to terraform Venus one day. So yeah, come check it out. I'm not kidding. This is post-quantum cryptographic algorithms. It's literally the first consumer post-quantum VPN in the world. You can get a 7-day free trial. So come support your boy. By the way, if you haven't heard, the new version is out. It looks exactly like this right now. The Mac version is only 2 days away. So come get the latest version of Cal if you already have it. The way to do that, guys, I should have explained before as well for everyone watching now. Uninstall your current version and download the new version and install it. That's all you got to do. And then you just log in and it'll work. So yeah, come get it. Don't know what this is. Oh, here we go. hyperspheres. Ooh. Gravitic flux. Okay. Kinetic grasp. Accretion. Cool. Experimental barrier. All right, so that's a barrier thing we saw. I mean, sure, that you could imagine such a thing if you could manipulate gravity, curvature of space-time, right? What do we got here? Accretion. So like I was saying, the accretion disk that would form if he was generating little black holes, that would happen, yeah. Gather a massive debris and throw it at I like what they've done, but that's, accretion is the stuff that, so with the black hole, an accretion disk forms because of the conservation of angular momentum, my friends. So angular momentum is like when stuff spins, right? And so have you ever looked at the sink before, or your bathtub, and when water goes into the hole, how does water go into the hole? It doesn't just go like in, does it? It swirls. Have you ever noticed? I'm sure you have, right? Like as water goes down the drain, it doesn't just go in, which you'd imagine it might if you didn't run the experiment. But it goes in, and then it all swirls, which is really cool. And what's going on here is actually, it's a physicsy thing. It's a conservation of angular momentum. So let's leave it at that. And so that's what would happen if you had a little black hole as well. Things would swirl. And as they swirled, right, they're coming closer to the event horizon, they actually speed up rapidly, and they get superheated, and it starts to glow, and you have this glowing accretion disk. So that's that. Kinetic grasp. Kinetic energy is like the energy of motion, right? So absorb projectiles in front of you and convert them into shields. I think they're just putting that in there because the guy's like clearly a physicist, right? So that's cool. Ultimate gravitic flux. Flux in physics is like the amount of something like passing through something. So like if you had like a barrier, the amount of stuff going through it is what you define a flux, right? If you quantify the amount of stuff going through it. Manipulate gravity to lift enemies into the air and slam them back down. Interesting. I don't know if that is a good way to call, like, I think that should be called something else, right? Because that's not really what flux is. So I think this barrier should have been called, the flux barrier or something, right? That would have been cooler. This should just be called, something else, to have these abilities. I could come up with them, but they've already gone. Hyperspheres launch 2 charges, which implode after a short duration, dealing damage in an area. That's kind of cool. Hyperspheres. Now, I'm not sure what they're talking about here. Maybe they're invoking the fact that, his ideas of gravity or something are invoking like hypergeometry or something. I don't know. But hyperspheres are cool nonetheless. I'm just not sure why he's relating those here. Why they are, sorry. I shouldn't say he. Anyway, it's very cool stuff nonetheless. Is there anything else? Let's see what they look like.
Ooh, let's take a look at this. First thing I want to show you guys is, it's a primary attack.
Nice.
You see that?
I love how they can bounce off things as well.
Bounces. Now, when you fire this, it fires both of the orbs. You can't just fire one and then keep another one in reserve. So if we fire it over there, well, it exploded because it hit debris. You notice it bounces? Look at that. That is super cool because you can kind of... It's going to be difficult to work out how to use this properly, I think. Like how to bounce it into locations.
Anyway, in terms of the actual game dynamics, I love this. Like, that's so fun. I wish Halo would come up with a little dynamic like that. Like the plasma grenades, but you can bounce them off things. That would be cool. What else is there?
Yeah. So, we suspected this would be an ability. So, basically rips a giant rock out of the floor and throws it forward. But there's something super cool about this. Now, if you use it at point-blank range, so if you use it on this guy, we just throw it right at this... Okay, I kind of missed. But I threw it at that dude there, and it sort of knocked him back. But what this will do is knock back and knock down, although it's very short duration. It's almost like a really quick knockdown and knock back. But it will be more effective the more range we've got. So if we do it at super close range... See? I mean, it did quite a bit of damage to that.
Very nice. Very nice.
Projected barrier. I've had a baby. And watch my shields as well. Watch this. Okay, that's not the ability. This is the ability. You see that? You see when the duration of the
What happened?
ability finished, I got additional shields. Now, this can give you an extra 400 shields. So you can, like, yeah, that is mental.
All right. What else?
Just eats them. Jeff did say on the Seagull stream that, yeah, they kind of regret that D.Va does that. Anyway, let's talk about the ultimate, right? Because I'm just going to show you this, guys.
Nice. Very cool.
Yeah, okay.
That's pretty cool, but I feel like it would have been cooler if he just like creates a black hole out in front of you. Not right in front of you, but like, or maybe in front of you, that would be cool as well. But like in the same distance, and a black hole just forms, and everyone starts spinning around it into like a black hole. That would have been sick, right? That would have been really cool.
Okay, so
I mean,
a
this
lot
looks
is
cool.
going on there, like an absolute lot. So, the bots are bugged on the PTR, so they die in midair. Now, what this does, right? Well, let's just charge an ultimate off as we speak.
Say one more time.
You can either disengage or engage with it. When they come out, we'll get them. So, I'm going to pop the ultimate, fly up into the air. I'm going to drop.
That's kind of what happens. I think they might have done it this way because it's much easier to do. I think it might have been really hard in game to in their engine to create like a thing sort of like that. I think that would be hard to do. Programming that wouldn't be easy. So I think this makes a lot more sense why they've done this. They've probably gone the easier route. Oh, there is one black hole, and if the enemy is in the air, is in it, they're stuck. Nice.
Duration. Any direction. See?
Wow, I love how it just keeps going back.
Actually, wow, that's cool. So you get more duration there. So you know.
Anyway, I got to play this game. It looks great.